Close your eyes and let yourself settle into complete comfort. Tonight, we're going to explore something you've seen countless times, but probably never really noticed. Something so common it's invisible. Something so fundamental to modern life that you literally couldn't live without it. Yet you've probably never given it a moment's thought. Tonight, we'll discover the surprising, revolutionary, world-changing history of the shipping container. Let your breathing slow and deepen. There's nowhere to go, nothing to accomplish. Just rest here and listen as we explore how a simple metal box transformed everything. How standardization changed the world. How one man's idea in 1956 enabled the life you live today. How the clothes you wear, the food you eat, the device you might be listening on. How all of it exists because of this box, this corrugated steel rectangle, this standardized container. Picture a shipping container. You've seen them. On trucks on the highway, stacked at ports, on trains, on cargo ships. A rectangular metal box, usually 20 or 40 feet long, 8 feet wide, 8.5 feet tall. Corrugated steel walls, flat steel roof, wooden floor, doors on one end, corner fittings at each corner, plain, industrial, utilitarian, boring even. But this boring box changed everything. Changed global trade, changed economics, changed what was possible, changed where things could be made, changed what things cost, changed how cities developed, changed labor, changed shipping, changed the world. Completely, fundamentally, irreversibly. Before, the shipping container, moving cargo, was nightmare. Was chaos, was expensive beyond belief, was slow, was prone to theft, was labor-intensive, was inefficient, was limiting what was possible. Preventing global trade from reaching its potential. Keeping costs high, keeping options limited, keeping the world smaller than it needed to be. The shipping container solved this. Not immediately, not easily, not without resistance, but eventually, completely. The solution was so simple it seems obvious in retrospect. Standardize the box, make all boxes the same size, make them stackable, make them strong, make them transferable between ships, trains, and trucks. Make them sealable, make them secure, make them boring, make them identical, make them everywhere. Let your body feel standardized. Feel how it fits comfortably within standard dimensions. Standard mattress sizes, standard doorways, standard furniture. Standardization enables comfort, enables efficiency, enables life as you know it. The container is ultimate standardization, ultimate efficiency, ultimate enabling technology. The numbers are staggering. About 200 million shipping containers exist worldwide. About 6 million are moving cargo at any given moment, on 50,000 cargo ships, on millions of trucks, on thousands of trains, moving 90% of everything, 90%, almost everything you own traveled in a shipping container at some point. The shirt you're wearing, the sheets you're lying on, the device nearby, the furniture in your room. Almost everything, all in boxes, all in standardized containers, all enabled by this one innovation. And you never think about it, never notice, never appreciate. The containers are background, our infrastructure, our invisible enabler of modern life. Like electricity, like internet, like roads, essential but unnoticed, fundamental but ignored, critical but taken for granted. Tonight we'll notice, we'll explore, we'll understand. The journey from chaos to order, from expensive to cheap, from slow to fast, from local to global, from impossible to inevitable, all because of a box. A simple, standardized, boring metal box. The story begins with problem, with suffering, with inefficiency so profound it limited human potential, with costs so high they prevented trade, with slowness so extreme it rendered many goods unshippable, with theft so rampant it made some routes uninsurable, with labor so intensive it employed armies of men in backbreaking work, with danger so constant it killed and injured regularly. This was shipping before containers. This was normal. This was accepted. This was how things were, for centuries, for as long as ships had carried cargo. The problems were considered inevitable, unsolvable. Just the cost of doing business, just how shipping worked, just reality. until one man looked at this reality and thought, there has to be a better way. There has to be. This is insane. This is wasteful. This is wrong. And he imagined something different, something simple, something that would seem obvious once it existed, but that no one had quite thought of before. He imagined the shipping container, and nothing was ever the same. Let yourself drift back to before, to 1950s, to world before containers, to chaos about to be solved, to inefficiency about to be eliminated, to old world about to be transformed. Let the story begin. Before containers, cargo came in every imaginable form. Barrels, crates, boxes, sacks, bales, rolls, each item different. Size, different shape, different weight, different handling requirements. Loading a ship meant fitting thousands of different pieces together, like world's worst jigsaw puzzle, taking days, taking weeks, taking enormous effort. This was called break bulk cargo. The cargo was broken into individual pieces. Each piece handled separately, loaded separately, stowed separately, secured separately, unloaded separately, delivered separately. The process was labor-intensive, was time-intensive, was expensive, was inefficient, was terrible. A typical cargo ship in 1950 might take a week to load, maybe longer. Longshoremen would work around the clock, hundreds of men, moving cargo piece by piece, from dock to ship, into holds, arranged carefully, stowed to prevent shifting, to maximize space, to enable unloading. Every piece requiring human hands, human decisions, human effort. The work was brutal. Heavy lifting, awkward shapes, dangerous conditions. Men were injured constantly, crushed by cargo, hit by swinging loads, fallen into holds, killed regularly enough that death was expected. Accepted, just part of the job. Longshoremen knew the risks, accepted them, had no choice, needed work, took chances, suffered consequences. The theft was endemic. Cargo sat exposed on docks for days, for weeks, waiting to be loaded or after being unloaded. Guarded inadequately, if at all. Temptation was enormous, opportunities abundant, losses accepted as cost of doing business. Some ports lost 20 to 30% of cargo to theft. 20 to 30%. Just gone. Stolen, vanished, considered normal, factored into costs, passed to consumers. Valuable cargo required special measures. Armed guards, secure warehouses, quick handling. Even then, theft occurred. The system was porous, was corrupt, was impossible to secure completely. Too many people involved, too many handling points, too many opportunities, too much temptation. The losses were staggering, were inevitable, were just how it was. Let your mind feel the chaos, the inefficiency, the waste, the suffering. Then let it go. Let yourself appreciate the order that came later, the efficiency, the security, the transformation. But first, understand what was being transformed. Understand the problem being solved. Understand why the solution mattered so much. The cost of shipping was prohibitive for many goods. Moving cargo from New York to Europe might cost more than the cargo was worth. Only expensive items could justify shipping costs. Only items that could absorb the expense. This limited trade, limited options, limited what could be manufactured. Where? Limited everything. A ton of cargo cost about $5.86 to load in 1956, just to load. Not including shipping, not including unloading. Just the labor of moving it from dock to ship. The unloading cost similar amount. So $12 per ton just in port costs, before the cargo went anywhere, before it crossed any water. Just the handling, just the loading and unloading. This was insane. Was barrier to trade, was limitation on what was possible. Time was the other cost. Ships spent more time in port than at sea. Much more time. A ship might spend 5 days at sea between New York and Europe, but spend 2 weeks in port, 1 week loading, 1 week unloading. The ship was idle most of the time. Not moving cargo, not generating revenue, just sitting, just waiting, just being loaded or unloaded slowly, inefficiently, expensively. This limited shipping capacity. Ships spent so much time in port that more ships were needed. More ships meant more capital investment, more crew, more maintenance. All to compensate for time wasted in port. all to accommodate inefficiency, all accepting terrible system as unchangeable, is just how things were. The ports were chaos, warehouses bursting with cargo, docks crowded with goods, temporary storage everywhere, confusion constant, mistakes frequent, wrong cargo loaded on wrong ships, damaged cargo accepted as inevitable. Lost cargo common, delayed cargo standard. The whole system was disaster, was barely functional, limped along because no alternative existed. Because this was how it had always been, because change seemed impossible. Labor unions controlled ports, controlled access, controlled work rules, controlled everything. The unions were powerful, were necessary to workers, were protective, but also were obstacle to efficiency, were resistant to change, were enforcing work rules that ensured maximum employment, maximum man-hours, regardless of efficiency, regardless of cost, regardless of waste. The work rules were elaborate, specified how many men required for each task, specified break times, specified procedures, all designed to ensure employment, to prevent automation, to protect workers from efficiency improvements. This was understandable from workers' perspective. Each efficiency threatened jobs, threatened livelihoods, threatened survival. The resistance was rational, was expected, was fierce. Any innovation had to overcome this resistance, had to accommodate labor, had to work within union constraints, or had to be so revolutionary that resistance became futile. That resistance collapsed. That new system became inevitable, despite opposition. The shipping container would be this revolutionary, would overcome resistance, but not easily, not quickly, not without struggle. Certain cargo was essentially unshippable. Fragile items couldn't survive handling, couldn't withstand being moved multiple times. Loaded, unloaded, reloaded, stacked, unstacked, restacked. Each handling risked damage, accumulated. Risk exceeded acceptable levels. So some goods couldn't ship, couldn't trade, couldn't move beyond local markets. The inefficiency limited possibilities, limited economic development, limited human potential. The system worked, sort of, barely. Goods moved, trade happened, economies functioned. But at enormous cost, enormous waste, enormous inefficiency. And everyone accepted this. Everyone assumed this was just reality, just how shipping worked, just unchangeable fact of transportation. No one imagined it could be different, could be better, could be revolutionized until Malcolm McLean, a trucking executive, not a shipping expert, not a maritime professional, an outsider, someone who looked at the system and saw absurdity, saw waste, saw opportunity, saw that the problem wasn't cargo, wasn't ships, was the interface, was the transfer from land to sea, was the loading and unloading, was the handling. That was the problem. That was what needed solving. His insight was simple, profound, obvious in retrospect. Don't load cargo, load the truck trailer, put the whole trailer on the ship. Don't handle individual pieces. Handle one piece. The trailer. Or better, just the box. Just the container. Standardized, stackable, transferable, sealable. Perfect. This insight would change everything, would transform shipping, would enable globalization, would make modern economy possible, would change your life fundamentally, even though you've never heard of Malcolm McLean, even though you've never thought about shipping containers, even though you take all this for granted. His idea, his vision, his persistence made your life possible, made modern world possible, made everything different. Let yourself rest in gratitude for innovation, for people who see problems and solve them, for improvements that make life better, for efficiency that reduces costs, for standardization that enables abundance, for boring solutions to complex problems, for metal boxes that changed everything. Malcolm McLean was born in 1913 in North Carolina, poor family, rural area, limited opportunities. He started work young, pumped gas, drove trucks, hustled, saved money. By 1930s, he owned one truck. By 1940s, he owned a small trucking company. By 1950s, he owned one of the largest trucking companies in the South, McLean Trucking. Successful, growing, but facing limitations. Trucks could only go where roads went, couldn't cross water efficiently, had to use ferries or go around. This limited routes, limited efficiency, limited growth. McLean saw this, understood this, wanted to solve this, wanted his trucks to cross water, to extend reach, to expand possibilities. The obvious solution was ferries. Roll trucks onto ferries, cross water, roll off, continue. This worked, but was expensive, was slow, was limited. Only certain routes, only certain locations, not scalable, not revolutionary, just incremental improvement. McLean wanted more, wanted breakthrough, wanted transformation. In 1953, McLean was at port, watching his trucks being loaded onto ship. More accurately, watching cargo from his trucks being unloaded, piece by piece, manually, slowly, expensively. He watched for hours, growing frustrated, growing angry, thinking, this is insane, why unload the truck? Why not just put the whole truck on the ship? This thought crystallized. Why handle cargo at all? Why not just move the container, the box? Leave cargo inside, sealed, secure, protected. Just move the box from truck to ship, from ship to truck, from truck to train, never opening it, never handling contents. Just moving the box, simple, obvious, revolutionary. McLean wasn't first to think about containers. Others had experimented. Military had used containers in World War II. Some shipping lines had tried trailer-on-ship concepts. But no one had committed fully. No one had built system around it. No one had standardized. No one had made it central rather than peripheral. McLean would bet everything on this idea, would transform his entire company, would risk fortune, would succeed. He sold McLean Trucking in 1955, couldn't own trucking company and shipping company simultaneously. Regulations prohibited this, so he chose shipping, chose containers, chose the future over the present, chose risk over safety, bought a small steamship company, Pan-Atlantic Steamship Corporation, later renamed Sealand. This would be his platform, his vehicle, his way to revolutionize shipping. McLean bought old oil tankers. World War II surplus ships, cheap, available. Not ideal for cargo, but workable, modifiable, good enough to start. He hired engineers, gave them simple brief, figure out how to carry trailers, make it work, make it efficient, make it economic. Figure it out. The engineers designed system, reinforced decks, created support structures, designed tie-down systems, made ships capable of carrying trailers stacked. The first ship carried 58 trailer trucks. 58. Each trailer loaded. With cargo, each sealed, each moved as unit. No individual pieces, no break bulk, just trailers, just boxes, just containers. Let your breathing be like containers. Standardized, consistent, stackable, each breath the same, each cycle predictable, reliable, efficient, no wasted motion, no unnecessary variation, just steady, calm, perfect repetition. April, pin 26, 1956. The Ideal X made its maiden voyage from Newark to Houston, carrying 58 trailers, each loaded with cargo. The loading took hours instead of days. The cost per ton dropped from $5.86 to $0.16. 16 cents instead of almost $6. A 97% cost reduction. 97%. This wasn't improvement. This was revolution. This was transformation. This was everything changing at once. The voyage was success. The ship arrived. The cargo was intact. The unloading was fast. The cost savings were real. The concept worked. McLean had proven it. Containers were viable, were transformative, were future. Now he just needed everyone else to agree. Needed industry to adopt. Needed ports to accommodate. Needed trucks and trains to adapt. Needed standardization. Needed acceptance. Needed revolution to spread. But there were problems. The trailers were heavy. The wheels and axles added weight. Added cost. Reduced cargo capacity. McLean realized, don't need the trailer, just need the box, just need the container. Remove wheels, remove axles. Remove everything except the box. Make it just a box. Stackable, standardized, perfect. The detachable container was born. A box, nothing more. Corrugated steel walls, flat steel roof, wooden floor, strong enough to stack, strong enough to lift. Strong enough to survive ocean voyage. Light enough to maximize cargo, simple enough to manufacture, cheap enough to build thousands. perfect enough to change everything. But what size? This was crucial. This was where standardization mattered. If containers were different sizes, couldn't stack efficiently, couldn't transfer between systems, couldn't be universal, the size had to be right, had to be standard, had to be agreed upon by everyone. This would be challenge. This would take years. This would require compromise, but was essential, was non-negotiable, was requirement for success. McLean chose 35 feet initially, based on truck-trailer dimensions, based on what roads would accommodate, made sense for land transport, for trucking, for integration with existing truck fleet, but wasn't ideal for ships, wasn't ideal for stacking, wasn't ideal for optimization, was compromise, was starting point, was good enough to begin. Sea-land grew. More ships, more routes, more containers. Newark to Houston. Houston to Puerto Rico, coastal routes, domestic shipping, proving concept, building business, creating infrastructure, making containerization real, making it normal, making it indispensable. Other shipping companies watched, skeptical initially. Dismissive. Containers were gimmick, were truck company solution, were not real shipping. Were not how maritime industry worked, were not serious. The dismissal was wrong, was short-sighted, was about to be proven catastrophically incorrect, but was understandable. Change is always resisted, especially by established industries, especially by those with investment in current system, especially by those who would lose from innovation. But the economics were undeniable. The cost savings were real. The efficiency gains were measurable. The advantages were obvious. Some companies started noticing, started considering, started experimenting. Matson Navigation, Graceline, others, small steps, tentative adoption. Careful experiments, testing whether McLean was right, whether containers really were future, whether revolution was actually happening. They discovered he was right. The revolution was happening. Containers were better, dramatically better, measurably better, provably better. The question shifted from, do they work, to, how fast can we adopt? The tipping point was approaching. The moment when innovation becomes inevitable. When adoption becomes necessary, when resistance becomes futile. That moment was coming, was rushing forward, was about to arrive. But first, many problems needed solving. Standardization, port infrastructure, cranes, trucks, trains, labor, regulations, international agreements. Everything needed to change. Everything needed to adapt. Everything needed to accommodate containers. The system needed complete transformation, needed rebuilding from ground up, needed revolution in how everything worked. This transformation would take decades, would cost billions, would disrupt industries, would destroy jobs, would create new jobs, would change cities, would enable globalization, would make modern economy possible, would make your life possible, would change everything. All because of a box, a standardized metal box, a shipping container. Let yourself rest in the knowledge that great changes start simply. Start with one insight. One person seeing differently, one innovation that seems small but isn't. The container changed everything, but started as one man thinking there has to be a better way. One man willing to risk everything. One man right about the future. One man whose name you didn't know until tonight, but whose idea shaped your entire life. By 1960, multiple shipping companies were using containers, but they weren't using the same containers. Sealand used 35-foot containers. Matson used 24-foot containers. Graceline used different dimensions still. Everyone had their own standard, their own size, their own specifications. This was disaster. This prevented true revolution. This limited benefits of containerization. A container that worked on Sealand. Ships couldn't go on Matson ships, couldn't use Matson cranes, couldn't fit Matson's infrastructure. And vice versa. Every company's containers were unique, incompatible, isolating. This meant shippers had to choose a single company, had to commit, had reduced competition, had higher prices, had fewer options. The lack of standardization preserved old systems' problems. Prevented full benefits of new system. Standardization required cooperation. required competitors agreeing on specifications, required giving up proprietary advantages, required thinking beyond individual company interest, required industry-wide thinking. This was difficult, was uncommon, was resisted. Each company wanted their size to be standard, wanted everyone else to adopt their specifications, wanted competitive advantage of defining standard. The military forced issue. The Department of Defense was major shipping customer. Used commercial carriers, wanted containers, but refused to deal with multiple incompatible systems, insisted on standardization, insisted on interoperability, insisted on single standard that all carriers would use. The military had power, had leverage, had budget large enough to demand compliance. The Maritime Administration convened meetings, brought together shipping companies, brought together military representatives, brought together engineers. The goal: agree on standard container dimensions, agree on specifications, agree on compatibility requirements, create single standard, enable true intermodality, enable full benefits of containerization. The negotiations were contentious. Each company argued for their preferred size. Each had reasons, each had investments, each had infrastructure built around their current containers. Changing would be expensive, would require rebuilding, would require scrapping existing containers. The resistance was rational, was expected, was fierce. Sea-Land wanted longer containers, 35 feet or 40 feet. More cargo per container, better economics for ocean shipping, efficient for long-haul transport. Matson wanted shorter containers, 20 feet or 24 feet, better for mixed cargo, easier to handle, more flexible. Truck companies wanted sizes matching trailer dimensions. Railroad wanted sizes matching rail car dimensions. Everyone had preferences. Everyone had arguments. Agreement seemed impossible, but compromise emerged. Two standard sizes, 20 feet and 40 feet, both 8 feet wide, both 8.5 feet tall. The 20-foot container, called 20-foot equivalent unit or TEU, became baseline. The 40-foot container, 2 TEU, became standard for most cargo. These dimensions weren't perfect for anyone, were compromise, were acceptable to most, were workable, were achievable, were standard. Let your body feel the power of standardization. Feel how standards enable compatibility, enable cooperation, enable efficiency. Your body fits standard sizes, standard beds, standard doorways, standard furniture. Standardization enables comfort, enables efficiency, enables life as you know it. The standardization included more than dimensions, included corner castings, corner fittings, steel blocks at each corner, precisely positioned, precisely sized. These corners had holes, specific dimensions. These holes accepted twistlocks, locking mechanisms that secured containers to ships, to cranes, to trucks, to trains. The corner castings were crucial, were what made stacking possible, were what made lifting possible, were what made everything work. The corner casting specifications were exacting. The holes had to be exactly right distance from corners, had to be exactly right size, had to be exactly right depth. Tolerances were tight, millimeters mattered. If castings weren't right, couldn't stack, couldn't lock, couldn't lift safely, couldn't use. The precision was essential, was non-negotiable, was requirement for interoperability. The ISO, International Organization for Standardization, created specifications. ISO 668 defined container dimensions. ISO 1496 defined structural requirements. ISO 6346 defined identification codes. These standards became international law, became requirements for international shipping, became universal, became what made global container system possible. The containers themselves are deceptively simple. Corrugated steel walls. The corrugation provides strength, allows thinner steel, reduces weight, increases cargo capacity. The corrugations run vertically. This provides vertical strength, allows stacking, allows weight distribution, allows containers to support enormous loads above them. The corners are solid steel, thick, strong, These corners bear all the load, all the weight, all the stress. The walls just maintain shape. The corners do the work. 4 corners supporting everything. Supporting. Multiple containers stacked above. Supporting crane loads during lifting. Supporting everything. The engineering is elegant, is efficient, is perfect. The roof is flat corrugated steel. Watertight, or supposed to be. Sealed seams, welded joints, creates enclosed space. Protected space. Cargo inside is safe from weather, from rain, from spray, from salt air. The enclosure is essential. Is what makes containers viable for valuable cargo, for sensitive cargo, for anything requiring protection. The floor is typically wood, marine plywood, treated for durability, for resistance to moisture, for strength. The wood floor is softer than steel, easier to secure cargo to, easier to repair, cheaper to replace. The floor takes abuse, takes forklift loads, takes cargo scraping, takes everything, gets replaced periodically, is considered consumable, is accepted cost of operation. The doors are on one end. 2 doors. Steel, reinforced. Hinged on sides. Swing open 270 degrees. Fully open for loading, for unloading, for access. Rubber gaskets seal doors. Create weather-tight seal, prevent water ingress, prevent air exchange. The seal is good, not perfect, but good enough. Adequate for purpose, protective enough for most cargo. Locking mechanisms, secure doors, locking bars, cam locks, multiple points of contact. The locks must be strong, must resist forcing, must prevent theft, must survive ocean voyage, must work reliably for years. The locks are simple, mechanical, robust. They work, they last, they secure. That's enough. Every container must have CSC plate, Convention for Safe Containers plate, metal plate mounted near doors, lists specifications, lists test dates, lists maximum weight ratings, lists country of origin. The CSC plate is legal requirement. Is proof of safety. Is certification that container meets standards. Is inspected regularly. Is maintained throughout container's life. The weight ratings matter. Each container has maximum gross weight. Total weight of container plus cargo. Typically 30,480 kilograms for 20-foot container. About 67,000 pounds. This is maximum. Exceeding risks structural failure. Risks safety. Risks accidents. The rating is enforced, is inspected, is regulated. Violations are fined, are prevented, are taken seriously. Tear weight is container's empty weight. About 2,300 kilo for 20-foot container. About 5,000 pounds, just for the box. The steel, the structure. This empty weight reduces cargo capacity, is overhead, is necessary cost, is accepted trade-off for the benefits, for protection, for security, for reusability, for everything containers enable. Maximum payload is difference between gross weight and tear weight. About 28,000 kilograms for 20-foot container. About 61,000 pounds. This is the cargo capacity, the useful capacity. What can actually ship? This payload capacity is enormous, is enough for most cargo types, is rarely fully utilized. Volume is usually limiting factor, not weight. Most cargo cubes out before weighing out, fills the space before reaching weight limit. The standardization succeeded. By 1970, most major shipping companies were using ISO standard containers. By 1980, containers dominated international shipping. By 1990, containers were universal. The holdouts had converted, had adopted, had joined revolution. The benefits were undeniable. The economics were irresistible. The future had arrived, and it was standardized, was boring, was perfect. Let yourself appreciate standardization. Appreciate how boring enables extraordinary, how uniform dimensions enable global system, how simple specifications enable complex trade, how metal boxes enable everything. The standardization is gift, is foundation, is what makes modern world possible. Thank someone you'll never know, someone in some standards committee, someone who insisted on precision, someone who demanded interoperability, someone whose boring work enabled your interesting life. The arrival of containers required ports to transform completely. Everything about traditional ports was wrong for containers. The docks were too narrow. The cranes were too small. The storage areas were inadequate. The access roads weren't designed for container trucks. Everything needed rebuilding. Everything needed reimagining. Everything needed massive investment. Traditional cargo required covered warehouse space, protection from weather, security from theft, expensive buildings, expensive maintenance. Containers changed this. The container itself was the warehouse, was the protection, was the security. Storage could be outdoors, just paved areas, just stacking space. Much cheaper, much simpler, much more efficient. But the paved areas needed to be huge. Containers stack 6 or 7 or 8 high, but stacking requires clear access, requires paths between stacks, requires organization, requires space, lots of space. Container ports needed tens of acres, hundreds of acres for major facilities. Land became critical resource. Ports expanded, pushed into water on reclaimed land, pushed into industrial areas, pushed away from urban centers. The cranes were the challenge. Traditional cargo cranes lifted a few tons, had short reach, were designed for break bulk cargo, for individual pieces. Containers required completely different cranes, required massive cranes, required specialized equipment, required enormous investment. The container crane, called ship-to-shore crane or portainer crane, is engineering marvel. Massive steel structure, taller than 20-story building, wider than highway, reaching over ship, reaching across deck. Accessing containers in every position, the scale is staggering, the precision remarkable, the speed impressive. The crane sits on rails, parallel rails along dock edge. The crane moves along these rails, positions itself along ship's length. Can access any point, can serve entire ship length. The rails must be perfectly straight, perfectly level. Any deviation affects crane operation, affects safety, affects efficiency. The rails are maintained obsessively, are inspected constantly, are critical infrastructure. The crane has legs, 4 massive legs, steel towers, connecting ground to overhead structure. The legs straddle dock area, create portal. Trucks drive, through portal. Enter under crane. Position under spreader. Spreader is lifted, container is lowered onto truck. Truck drives through opposite side. System flows, continuously, efficiently, beautifully when working well. The trolley moves along. Boom. Horizontal structure extending over water, over ship. The trolley travels out and back. Positions spreader over container. The boom can be 200 feet long or more, must support enormous loads, must resist wind, must function in all weather, must last decades. The engineering is extreme, is pushed to limits, is remarkable achievement. The spreader is what grips container. Rectangular frame, same dimensions as container top. Has 4 twistlocks, 1 at each corner. The twistlocks engage corner castings, rotate, lock. The container is secured, is lifted, is moved, is placed. The twistlocks unlock, disengage. The spreader lifts away, ready for next container. The twistlock mechanism is simple. Rotating lock, cam-based. When rotated, engages casting hole, creates mechanical lock. Gravity helps, weight holds lock closed. Opening requires manual unlocking, or automatic unlocking for modern cranes. The simplicity is strength. Few moving parts, robust, reliable, works for decades. Let your breathing be lifted like containers, smooth, controlled, precise. Each breath lifted by muscles, by diaphragm, by mechanics you don't think about. Working automatically, working perfectly, enabling life, enabling rest. Like cranes enable trade, enable efficiency, enable modern economy. The crane operator sits in cab, high above ground, level, with container tops. Enclosed cab, climate-controlled, instrumented, multiple cameras, multiple displays, showing different angles, showing spreader position, showing container alignment. The operator has godlike view, has complete information, makes decisions constantly, positions precisely, moves safely, operates efficiently. The operation is skilled work, requires training, requires practice, requires judgment. The containers weigh tons. The movements must be smooth, the placement must be precise. Stacking requires millimeter accuracy. Containers must align perfectly. Castings must meet correctly. Any misalignment risks damage, risks instability, risks disaster. Modern cranes have automation, computer assist, sensors detecting positions, software optimizing movements, anti-sway systems preventing container swing. The automation makes operation faster, safer, more consistent, but still requires skilled operator, still requires human judgment, still requires experience. The automation assists, doesn't replace, enhances, doesn't eliminate. A skilled operator can move 30-40 containers per hour. That's one container every 90-120 seconds. Lift from ship, move to dock, place on truck or on ground, return for next container, continuously, hour after hour. Shift after shift, day after day. The pace is relentless, the precision constant, the skill impressive. The fastest ports can unload largest ships in 24-36 hours. Ships carrying 15,000 or 20,000 containers, completely unloaded, reloaded with outbound. Cargo, return to sea. In a day and a half. This would have been impossible with break bulk. Would have taken months. Would have taken years, probably. The efficiency gain is immeasurable, is transformative, is revolutionary. The port. Transformation costs billions. Billions per port. Hundreds of billions globally. The cranes alone cost millions each. The land costs millions. The paving, the utilities, the access roads, the rail connections. Everything expensive, everything necessary, everything paid for. By shipping companies, by port authorities, by governments, by everyone recognizing that containers were future. That investment was necessary. That transformation was inevitable. Some ports couldn't transform, couldn't afford investment, couldn't acquire land, couldn't build facilities. These ports declined, lost business, lost relevance, became backwaters. The concentration increased. Few major ports handling most traffic. Economies of scale driving consolidation, driving centralization, driving specialization. New ports were built, in locations chosen for container operations, deep water for large ships, flat land for container, storage, good highway access, good rail access, away from urban centers where land was cheap and available. The new ports were purpose-built, were optimized, were designed around containers, around efficiency, around throughput. The environmental impact was debated. The ports required dredging, required reclaimed land, required ecosystem disruption. The operations generated pollution. Diesel from trucks, emissions from ships, noise, light pollution. Residents near ports complained, organized, protested. The ports responded with mitigation, with buffers, with improving technology, with cleaner operations. The balance shifted, improved, continues improving. The transformation wasn't instant, took decades. First ports converted in 1960s. Last major ports completed transformation in 1990s and 2000s. Some ports are still converting, still building capacity, still adapting. The process continues. The evolution continues. The investment continues. Because trade continues growing. Containers continue multiplying. Ships continue getting larger. Capacity needs continue increasing, but the fundamental transformation is complete. Containers 1 became universal, became standard, became how trade works. The ports adapted, evolved, transformed, and in doing so, enabled modern economy, enabled global trade, enabled everything you own, everything you eat, everything you wear. All came through container ports, all moved in boxes, all transported by system that didn't exist 70 years ago. All enabled by transformation, by investment, by vision, by commitment to future. Let yourself rest in the present, in the fully transformed world. In the world where containers are normal, where trade is efficient, where costs are low, where abundance is reality, where choice is enormous, where everything comes from everywhere. This world was created, was built, was invested in, was transformed from old world, from inefficient world, from expensive world, from limited world. And you benefit without effort, without cost beyond normal prices, without even noticing. That's the gift, that's the transformation, that's the revolution accomplished. Making a shipping container seems simple. Bend some steel, weld it together. Add a floor and doors. Done. But simplicity is deceptive. Creating container that survives ocean voyage, that stacks 8 high, that lasts 20 to 30 years. That remains watertight. That protects cargo. This requires precision, requires quality, requires engineering. The process begins with steel, Corten steel specifically. Weathering steel. This steel contains copper, chromium, nickel. These elements create oxide layer, rust layer that protects underlying steel. The rust looks ugly but prevents deeper corrosion, prevents structural degradation, allows container to survive harsh marine environment without painting, without constant maintenance. The Corten steel is essential, is why containers last, is why they work. The steel arrives in flat sheets, coils of steel, loaded on rollers, fed into corrugation machines. The corrugating process cold forms the steel, presses it into wave pattern, creates valleys and peaks. This corrugation increases stiffness. A flat steel sheet bends easily. Same thickness corrugated steel is rigid, can support loads, can resist deformation. The corrugation is engineering, is strength through geometry. The corrugation depth and spacing are standardized. Specific measurements, precise dimensions. Not decorative, not arbitrary. Engineered for optimal strength to weight, a ratio, for maximum cargo capacity, for minimum material, for maximum efficiency. Every measurement intentional, every specification calculated, every choice optimized. The corrugated sheets are cut, laser cutting typically, computer controlled, precise. The cuts must be accurate, must match specifications, must leave proper dimensions for assembly, for welding, for fitting. Errors here propagate through entire container. Create misalignments, create quality issues, create failures. The cutting is first critical step. Must be perfect, must be right. Corner posts are cut from solid steel, thick steel. These posts are structural members. Bear all vertical load. Must be strong. Must be precise. Must align perfectly with castings. The posts are machined, drilled, prepared for corner casting attachment, for wall attachment, for roof attachment, for everything. The corner posts are heart of container. Are what makes stacking possible. Are what makes containers work. Corner castings are forged steel, high-strength steel, cast in molds, machined to final dimensions, the holes drilled precisely, tolerances tight. The castings must meet specifications exactly, must fit Twistlocks perfectly, must align with all other containers, must work universally. The casting quality determines container quality, determines safety, determines everything. The assembly begins with floor frame, steel frame, rectangular, precisely sized. The frame is welded, strong welds, inspected welds. The frame must support floor, must support cargo, must remain flat, must remain true. Any distortion prevents proper stacking, prevents proper functioning, prevents certification. The floor is installed, marine plywood typically, hardwood, treated. Thick, about an inch or more, screwed into frame, many screws. The floor must support 60,000 plus pounds, must support forklift traffic, must support cargo concentrated in small areas, must last years. The floor is stressed, is replaced periodically, is accepted consumable, but must last years before replacement. Let your body feel supported like cargo in container, distributed weight, stable surface, secure hold. The floor beneath you supports you completely, requires no thought, no effort, no awareness, just works, just supports, just enables rest. Side walls are attached, welded to floor frame, welded to corner posts. The welding is critical, must be strong, must be continuous, must be watertight, must last. Poor welds fail, create leaks, create weak points, create problems. The welders are skilled, are certified, are tested regularly. The quality of welding determines quality of container. End wall is attached. One end has doors. This end has door frame. Door posts, door header, all welded, all reinforced. The door opening is precise. Must be exact size. Doors must fit, must seal, must operate, must last. The door frame takes abuse, takes stress from opening and closing, takes impacts from loading, must survive everything. The other end is solid wall, corrugated steel, welded, all around. This wall is simplest, just steel, just structure, but must be strong, must resist pressure from cargo inside, must support stacking loads, must remain intact. The wall does its job, silently, invisibly, essentially. The roof is installed, corrugated steel, welded to top of walls, welded to corner posts, creates enclosed box. The roof must be watertight, must resist rain, must resist spray, must resist hose down cleaning. The welding is careful, the seams are sealed. The result is protection, is enclosure, is container. The doors are fabricated separately. Steel frame, steel skin, reinforced, hinged. The hinges are massive. Must support door weight. Must allow 270-degree swing. Must survive thousands of open-close cycles. Must not fail. The hinges are maintenance points. Are inspected. Are lubricated. Are critical components. Door seals are installed. Rubber gaskets, all around door perimeter. The gaskets compress when doors close, create seal, prevent water ingress. Prevent air exchange. The seals wear. Are replaced periodically, are important for cargo protection, for maintaining container condition. Locking mechanisms are installed, locking bars, cam locks. The mechanisms are mechanical, simple, robust, must work reliably, must resist forcing, must secure cargo, must prevent theft. The locks are standardized, are same across all containers, are universal. This universality enables interoperability, enables use of same tools, same procedures, same training, everywhere. The assembled container is inspected, visually, dimensionally, every weld checked, every alignment verified, every specification confirmed. Defects are corrected, reworked, fixed. Containers failing inspection are scrapped. Quality is non-negotiable. Standards are strict. Compliance is verified. The CSC plate is installed. Riveted to end wall, near doors, visible, accessible. The plate lists specifications, lists test dates, lists certifications. The plate is legal requirement, is proof of compliance, is necessary for international shipping. Without valid CSC plate, container cannot ship, cannot be used, cannot participate in global system. The container is tested, loaded to maximum weight. Inspected for deformation, for stress points, for failures. Some containers are stacked and loaded. Testing stacking strength, testing structural integrity, ensuring they meet requirements, ensuring they're safe. Ensuring they'll survive real-world use. Paint is optional. Many containers aren't painted. The Corten steel doesn't require it. Rusts beautifully, protects itself. But shipping companies often paint containers. Corporate colors, logos, branding. The paint isn't structural, is cosmetic, is marketing. But also provides some additional protection, some additional barrier against salt and moisture. The painted containers are dried, cured. The paint must adhere, must flex with steel, must resist chipping, must last years. The paint quality matters, affects appearance, affects pride, affects brand. Companies care about how their containers look, care about cleanliness, care about condition. The paint helps, protects, identifies. The manufacturing process is efficient. Modern facilities produce dozens of containers daily. The process is standardized, is automated where possible, is quality controlled throughout. The containers are identical, are interchangeable, are perfect in their boring uniformity, perfect in their standardization, perfect in their adequacy. The cost varies. A new 20-foot container costs about $3,000 to $4,000. A 40-foot container costs $4,000 to $6,000. These costs seem high, But containers last 20, 30 years, make thousands of voyages, carry millions of dollars worth of cargo. The cost per use is tiny. The return on investment is enormous. The economics work, the system works, everything works. Let yourself appreciate manufacturing. Appreciate skilled workers welding, cutting, assembling, creating these boxes. These boring, essential, world-enabling boxes. The workers don't think about global trade, don't think about enabling your life. Just do their job, weld their welds, make their quotas, go home. But their work matters. Their precision matters. Their skill enables everything. Enables global economy. Enables your comfort. Enables your choices. Thank them silently. Workers you'll never meet. Who made boxes you'll never see. That carried things you own. The Vietnam War accelerated container adoption. Dramatically, unexpectedly. The military's logistical challenges were immense. Supplying troops across Pacific, maintaining equipment, feeding soldiers, arming units. Everything requiring transport. Everything requiring efficiency. Everything benefiting from containerization. Before Vietnam, military shipping used traditional methods. Break bulk cargo, individual pieces, pallets, crates. The inefficiency was staggering. Ships took weeks to load, took weeks to unload. Cargo sat exposed, was vulnerable to theft, was vulnerable to damage, was vulnerable to weather. The losses were enormous, the delays unacceptable. Something had to change. The military embraced containers, not immediately, not completely, but increasingly, progressively, desperately. The containers solved problems, reduced theft, increased security, accelerated shipping, improved efficiency. The benefits were measurable, were substantial, were necessary. McLean's Sealand won contracts, shipping to Vietnam, supporting military operations. This was validation, was proof that containers worked, that they scaled, that they served enormous demand, that they handled most challenging logistics. The military's adoption legitimized containers, proved them to skeptics, demonstrated capabilities beyond commercial shipping. The military also drove standardization, refused to work with proprietary containers, demanded ISO compliance, demanded interoperability, demanded universal specifications. This pressure forced shipping companies to standardize, forced adoption of common dimensions, forced convergence on 20-foot and 40-foot standards. The military's leverage accelerated what was already happening, made inevitable what was already probable, compressed timeline, forced decisions. The infrastructure investment accelerated. Ports upgraded to handle containers, to serve military demand, to support war effort. The investment was government-funded, was justified by national security, was politically acceptable even when expensive. The money flowed. The transformation accelerated. The container revolution gained momentum. The returning containers needed cargo. Empty containers returning from Vietnam were waste, were lost opportunity. Sealand sought cargo, sought anything to fill boxes on return voyage, found opportunities in Asia, found manufacturing, found exports, found beginnings of Asian export economy. The empty containers returning from war became foundation for peacetime trade, became enabler of Asian manufacturing boom, became connector between Asia and America. Japanese manufacturers embraced containers, Korean manufacturers. Taiwan, Hong Kong, they saw opportunity, saw efficient transport, saw access to American markets, saw path to growth. The containers enabled exports, enabled competition, enabled manufacturing revolution, the goods flowing. Back in returning containers were beginning, were hint of what was coming, were preview of globalization. The manufacturing shifted. American companies saw lower costs in Asia, saw cheaper labor, saw opportunity to reduce expenses. The containers made this possible. Made shipping cheap enough, made coordination feasible, made quality control manageable. Without containers, offshore manufacturing would be limited, would be expensive, would be impractical. Containers removed barriers, removed limitations, enabled possibilities. Let your consciousness shift like manufacturing, from one place to another, from active to restful, from engaged to sleeping. The transition smooth, natural, enabled by systems you don't think about. Your body knows how to sleep. Knows how to shift states, knows how to rest, trust it, allow it. Let transition happen. The environmental consequences were unanticipated. The containers enabled globalization. Globalization increased trade. Trade increased shipping. Shipping increased emissions, increased pollution, increased environmental impact. The connection wasn't obvious initially, wasn't considered, wasn't factored into decisions. The consequences emerged slowly, are still emerging, are still being addressed. The labor consequences were severe. Longshoremen lost jobs, many jobs, thousands of jobs. The containerization eliminated manual handling, eliminated breakbulk work, eliminated most traditional port employment. The unions resisted, fought, struck, but couldn't stop progress, couldn't prevent automation, couldn't preserve jobs that containers made obsolete. Some workers transitioned, learned new skills, became crane operators, became container handlers, became logistics workers. The new jobs were different, fewer, higher skilled, better paying sometimes, but fewer. Many fewer. For every 100 men loading breakbulk cargo, maybe 5 handled containers. The productivity gain was somebody's job loss. The efficiency was somebody's unemployment. The progress was somebody's suffering. This pattern repeated globally. Every port that containerized eliminated jobs, eliminated careers, eliminated communities. The efficiency gains were distributed broadly. Lower costs for everyone. The job. Losses were concentrated. Specific workers, specific families, specific neighborhoods. The benefits were abstract, the losses concrete. The trade-off real, brutal, unavoidable. Society benefited overall. Lower shipping costs meant lower prices, meant more choices, meant higher living standards. The benefits exceeded losses in aggregate. But aggregates don't help individuals, don't help families losing income, don't help communities losing purpose. The transition was painful, was resisted, was eventually accepted because inevitable, because unstoppable, because progress doesn't wait for consensus, doesn't pause for suffering. Just happens. The Vietnam War ended. The military demand decreased, but civilian demand exploded. The infrastructure was built, the systems were established, the investments were made, the standards were set, the containers were available, the pieces were in place. Global trade was ready to boom, was ready to transform, was ready to create modern economy. The boom came. Manufacturing spread across Asia. Exports surged. Container traffic multiplied. Ports expanded. Ships grew. The system scaled. What started as innovation became foundation, became infrastructure, became necessity, became how the world works. And few noticed, few understood, few appreciated. It just became normal, became background, became invisible foundation for visible life. You're part of this. Your life is enabled by containers, by shipping, by global trade, by cheap transport, by efficient logistics. Every purchase, every meal, every possession, connected to containers. Connected to ships, connected to ports, connected to system that didn't exist when your grandparents were young, connected to revolution that transformed everything, connected to boxes, boring metal boxes, standard metal boxes, essential metal boxes. Modern container ships are enormous, impossibly large, almost incomprehensibly huge. The largest ships carry over 24,000 containers, 24,000. Each container weighing up to 30 tons loaded. The total capacity is staggering. The scale defies understanding. These ships are floating cities, are engineering miracles, are economic powerhouses. The ships are around 300 feet long, about a quarter mile. Longer than aircraft carriers, longer than skyscrapers are tall. The deck area exceeds 4 football fields. The cargo capacity exceeds any other vehicle ever created. Nothing on land, in air, or on sea moves as much cargo per trip. Nothing approaches these ships' efficiency. Nothing scales like this. The hull is steel. Thick steel plates, welded together, creating structure strong enough to survive ocean storms, strong enough to carry hundreds of thousands of tons, strong enough to last decades. The welding alone is engineering challenge. Miles of welds, all must be perfect, all must be inspected, all must hold. The hull integrity is life or death. Is survival, is everything. The containers stack on deck. 9 high sometimes, 10 high. The stacks visible from miles away. The ship looks top-heavy, looks unstable, but isn't. The engineering accounts for this. The weight distribution is carefully calculated. The ballast is adjusted. The stability maintained. The ship remains safe, remains seaworthy, remains upright even in storms. Below deck, more containers in holds. The holds are cellular, are structured with vertical guides. The containers slide into cells, are guided, are aligned, are secured. The cellular structure prevents shifting, prevents cargo movement, prevents disaster. The holds are dark, are ventilated, are designed specifically for containers, for nothing else, for maximum capacity, for maximum efficiency. The stacking is precisely calculated. Software determines placement, considers destination, considers weight, considers stability. Containers for same port stack together. Heavy containers go low, light containers go high. Balance is maintained, stability preserved. Nothing random, nothing casual, everything planned, everything optimized, everything essential. The Twistlocks secure everything, simple mechanical locks, rotating cams, engaging corner castings, but millions of them. Every container interface, locked, every connection secured. The Twistlocks bear tremendous forces. Waves rock ship, containers want to shift, want to slide, want to fall. The Twistlocks prevent this, hold everything, keep cargo safe, keep ship balanced, keep system working. Let your breathing be secured like containers, locked in rhythm, stable, consistent, wave after wave, breath after breath, reliable, automatic, secure, nothing shifting, nothing changing, just steady, calm breathing, supporting life, supporting rest, supporting sleep. The engines are massive, multi-story engines, diesel engines, turning propellers large as houses, creating thrust to move hundreds of thousands of tons. The fuel consumption is enormous, tons per day. The engines run continuously, for weeks, for months, never stopping, just running, just pushing, just moving. The reliability required is extreme, the maintenance intensive, the operation expensive. The bridge is computerized, navigation systems, radar, GPS, automatic steering, weather monitoring, communications. The captain oversees, but computers control. The route is programmed, the speed optimized, the fuel consumption monitored, the efficiency maximized. Human judgment remains important, remains necessary. But computers do most work, most calculations, most operations. The crew is small, surprisingly small, maybe 20 to 25 people. Operating ship carrying $300 million of cargo. The automation enables this, the systems enable this, the reliability enables this. Compare this to breakbulk ships requiring hundreds of crew. The efficiency gain is total, is transformative, is allowing one person's labor to accomplish what once required dozens. The loading and unloading is choreographed. Multiple cranes working simultaneously, containers moving continuously, every container's position known, every movement tracked, every placement optimized. Software coordinates, everything. Humans supervise, machines execute. The operation is ballet at massive scale, is symphony of efficiency, is engineering art. The ships call at major ports: Singapore, Shanghai, Rotterdam, Los Angeles. Ports designed for these massive ships, deep water channels, enormous cranes, vast container yards. Everything scaled to match ships, everything optimized for speed. Ships spend hours in port, not days, not weeks, hours. The turnaround is remarkable, is essential, is economic necessity. The economics require this speed. Ships are expensive, cost hundreds of millions to build, cost thousands of dollars per day to operate. Every hour in port is lost revenue, is wasted capacity, is inefficiency. The pressure to load and unload quickly is enormous, is driving force, is shaping everything. The shipping routes are optimized. Computers calculate best paths. Consider weather. Consider fuel, consider schedules, consider everything. The routes are precise, the timing tight, the system choreographed globally. Ships arriving at ports at specific times. Containers connecting to trains, to trucks, to other ships, everything timed, everything coordinated, everything working. When it works, it's invisible. Goods flow, arrive on time, cost little. You never think about the ship, never consider the journey, never appreciate the complexity. The container arrives, the goods are there. That's all that matters. That's all you know. The system works so well it disappears, becomes background, becomes assumed, becomes invisible infrastructure for visible life. When it fails, chaos emerges. Supply chain disruptions, empty shelves, delayed goods, frustrated consumers, economic impacts. The COVID pandemic revealed fragility, revealed dependencies, revealed how much we rely on this system, on containers, on ships, on ports, on everything working perfectly. The disruption was painful, was revealing, was educational, but the system recovered, adapted, improved, supply chains rebuilt. Container availability increased, ship capacity grew, the resilience proved, the system bent, but didn't break. The containers kept moving, the goods kept flowing. Life continued. Because the system is robust, is redundant, is essential, cannot be allowed to fail, will not fail. Too much depends on it. Your life depends on it. On these ships, on these containers, on this system. Almost everything you own traveled on container ship. In container, across ocean, from factory to you. The journey took weeks. Cost cents per pound, worked invisibly, enabled your choices, enabled your comfort, enabled your life. Let yourself rest like cargo in container, secure, protected, on journey to destination. The destination is sleep. The container is your body. The protection is safety. The journey is natural, is inevitable, is happening now. Just rest, just allow, just sleep. The shipping container transformed global economics, changed what was possible, changed what was profitable, changed where things could be made, changed everything. The cost reduction enabled new possibilities, new industries, new trade patterns, new global economy. Before containers, manufacturing stayed local. Transportation costs were too high. Only valuable goods could afford to ship long distances. Only goods with high margin. Only goods where transportation was small fraction of in value. This limited what could trade. Limited global integration. Limited economic possibilities. Containers changed this calculation. Transportation costs dropped to nearly zero. $1 per pound became cents per pound, became fractions of a cent. Suddenly, anything could ship. Anything could trade. Manufacturing could locate anywhere. Could optimize for costs, for labor, for resources, for anything except transportation, because transportation became cheap enough not to matter. Factories moved, from high-wage countries to low-wage countries, from America to Asia, from Europe to Asia. The movement was logical, was economically rational, was enabled by containers. Without cheap shipping, offshoring wouldn't work, wouldn't make sense. Containers made it possible, made it profitable, made it inevitable. The job losses in developed countries were substantial. Manufacturing employment fell. Factories closed, communities declined. The Rust Belt rusted. The industrial heartland deindustrialized. The jobs moved. The wealth moved. The economic base eroded. The consequences were severe, are ongoing, are still reshaping society, but consumers benefited. Prices fell. Choices expanded. Living standards rose. The average person could afford more, could buy more, could enjoy more. The benefits were distributed broadly. The costs concentrated. This pattern repeated. Repeated in every trade agreement. Repeated in every efficiency gain. Repeated always. The developing countries benefited enormously. China especially. Manufacturing employment surged, incomes rose, poverty decreased. Hundreds of millions escaped poverty, achieved middle-class status, transformed lives, transformed societies, transformed the world. The container enabled this, made this possible, made this the greatest poverty reduction in human history. The environmental costs are contested. The shipping industry is efficient per ton-mile, more efficient than air, more efficient than truck. But total emissions are enormous. Thousands of ships burning fuel, creating pollution, contributing to climate change. The efficiency per unit is good. The total scale is overwhelming. The impacts are real, are measurable, are concerning. The industry is adapting. Developing cleaner fuels, improving efficiency, reducing emissions. Slow progress, but progress nonetheless. The regulations are tightening, the pressure increasing, the technology improving. The ships of 2050 will pollute less than ships of today. Will be cleaner, better, more sustainable, but still numerous, still moving cargo, still essential. The geopolitical implications are profound. Global supply chains create dependencies, create vulnerabilities, create power dynamics. Countries controlling ports control trade. Countries controlling manufacturing have leverage. The complexity creates both resilience and fragility, redundancy and concentration, strength and weakness, all simultaneously. The pandemic exposed vulnerabilities, single-source dependencies, just-in-time fragility, concentration risks. Companies are reconsidering, diversifying, building redundancy, accepting higher costs for greater security. The pendulum swings from maximum efficiency toward maximum resilience. The balance shifts, will shift back, will oscillate, will never settle. The container system is now infrastructure, is essential infrastructure, like roads, like power grid, like internet. Cannot remove it, cannot replace it, can only improve it, can only maintain it, can only depend on it. The world runs on containers, literally. The goods must flow, the containers must move, the ships must sail. Everything depends. On this, you depend on this, on containers, on ships, on ports, on system working, on goods arriving, on trade flowing. Your job might depend on it, your income certainly benefits from it, your standard of living requires it, your choices assume it, your life is shaped by it, all because of metal boxes, because of standardization, because of a one man's idea. Because of decades of investment, because of system that works so well, you never think about it. Let yourself release thinking about it, release analyzing, release understanding, just accept, just appreciate, just rest in the world. That is, in the abundance that exists, in the choices available, in the life possible. All enabled by containers, all enabled by boring metal boxes, all enabled by revolution you've never noticed, until tonight, until now, until this moment of recognition, before releasing back into not noticing, into taking for granted, into living normally in extraordinary world. Shipping containers last 20-30 years in service. Then they're retired, but they don't die, don't disappear, don't cease existing. They get repurposed, get reimagined, get transformed from transport to structure, from temporary housing for cargo, to permanent housing for people, for businesses, for art, for imagination. Container architecture emerged in 2000s. Architects saw potential, saw structural strength, saw weatherproof enclosure, saw affordable building block, saw possibility. The containers are strong, are stackable, are modular, are available, are cheap, perfect building material. Perfect starting point for innovative architecture. The first container homes were simple. One container. Interior finished. Windows cut. Insulation added. Doors installed. Basic home. Small home. About 160 square feet for 20-foot container. About 320 square feet for 40-foot. Tiny homes before tiny homes were trend. Affordable housing. Off-grid possible. Portable if needed. The simplicity appealed. The cost appealed. The quickness appealed. Then architects got creative. Multiple containers. Stacked. Arranged. Connected. Creating larger homes, more interesting designs, cantilevers, overhangs, open spaces. The containers became building blocks, became Lego for adults, became medium for architectural expression. The results were striking, were beautiful, were proving that containers could be more than utilitarian, could be aesthetic, could be architectural. The insulation challenge required solving. Steel conducts heat. Single-walled containers are hot in summer, cold in winter. Condensation forms, rust develops. The solution is insulation, spray foam typically, applied to interior walls, creating thermal barrier, creating comfort, creating livability. The insulation isn't cheap, isn't optional, is essential, is what makes container housing work. The windows and doors require cutting steel, reinforcing openings. The steel must be cut precisely. The structure must be reinforced to compensate for removed material. The openings must be framed, must be sealed, must be insulated, must be done correctly. Poorly done modifications weaken structure, create leaks, create problems. Professional work is necessary, is worth the cost. The appeal is partly environmental. Recycling containers, giving them new life, saving steel, reducing waste. The environmental claim is complicated. The modifications require energy, require materials, require transport. The savings are less than pure recycling, but better than landfill, better than scrapping, better than waste. Container offices emerged. Companies needed space, needed flexibility, needed affordability. Containers provided all three. Startup offices, construction site offices, retail pop-ups, coffee shops, information booths. The containers became versatile, became adaptable, became seen everywhere. Some businesses embraced aesthetic, left corrugated steel visible, left industrial character, made it part of brand, made it cool, made it desirable. The container aesthetic became trendy, became aspirational, became deliberately chosen rather than accepted necessity. Container hotels appeared. Budget hotels, hostels, tourist accommodations, stacked containers creating multi-story buildings. Each container a room, efficient, affordable, fast to build. The concept worked, spread, multiplied, now exists in multiple countries, multiple cities. Proving model works, proving market exists. Container schools in developing countries, quick to deploy, affordable, adequate, providing education where traditional buildings too expensive, too slow. Container clinics, container emergency shelters, container disaster relief. The containers are versatile, are deployable, are practical, serving needs beyond original purpose, beyond transportation, beyond cargo. The art installations emerged. Artists saw possibility, saw medium for expression, container sculptures, container galleries. Container performance spaces. The containers became canvas, became material, became statement about globalization, about consumption, about commerce, about industrial society. The installations provoke, question, challenge, make visible what was invisible. Make strange what was ordinary. Let your mind be repurposed like containers. From active to resting, from working to sleeping, from one state to another. The transformation natural. The new purpose emerging. The transition smooth. From containers carrying cargo to containers housing dreams. From metal boxes shipping goods to metal boxes sheltering people. The adaptability, the versatility, the possibility, all metaphor. All reminder. All teaching that change is possible, that transformation happens, that new purposes emerge, that nothing is only what it was. Everything can become something else. The debate continues. Are container homes sustainable? Are they affordable after modifications? Are they better than traditional building? The answers depend on location, on climate, on costs, on values, on priorities. The containers offer option, offer possibility, offer choice. Where the best choice depends on circumstances, on needs, on preferences, on countless variables. But the containers exist, millions of them, retired from shipping, available, for repurposing, for transformation, for new life. The supply is abundant, the possibilities limited only by imagination, by creativity, by willingness to see differently, to think differently, to build differently. The containers wait, ready, willing, capable. Just metal boxes, but also blank canvas. Also opportunity, also possibility. Your consciousness is ready for transformation too. Ready to shift from waking to sleeping, from active to resting, from engaged to released. The transition approaching, the change imminent, the new state emerging. Just allow it. Just accept it. Just let consciousness transform. Let awareness fade. Let sleep arrive. Like container being repurposed. Like metal box becoming home. Like transport becoming shelter. Like one purpose completing, another beginning, the cycle continuing, the transformation happening, The change arriving, now. We've traveled far tonight, from chaos of break bulk cargo to order of containerization, from expensive inefficiency to cheap abundance, from localized trade to global economy, from McLean's insight to modern reality. All because of box, simple metal box, standardized, boring, essential. The shipping container is most successful innovation you've never thought about. Most impactful technology you take completely for granted. Most transformative invention you never notice. 90% of everything you own traveled in one. 90%. And you never think about them, never notice them, never appreciate them. This is perfect. This is how infrastructure should work. Should be invisible. Should be reliable. Should be taken for granted. The best technology disappears, becomes background, becomes assumed, becomes foundation for everything else. The container achieved this completely, perfectly, totally. Your life would be impossible without containers. Literally impossible. The clothes you wear were made across ocean, transported in containers. The device you're listening on contains components from dozens of countries, all transported in containers. The food you eat includes ingredients from around the world, transported in containers. Your home contains furniture, electronics, decorations, everything. All transported in containers, all enabled by this simple innovation. This boring metal box. The innovation wasn't technology, was standardization, was agreement, was cooperation. Was everyone accepting same dimensions, same specifications, same systems? The magic wasn't engineering, was compatibility, was interoperability, was universal. The revolution was boring, was administrative, was about standards and agreements and specifications. Not exciting, not dramatic, but transformative, completely transformative. This is lesson, the most powerful. Changes are often boring, are invisible, are about systems and standards and coordination, not about flashy innovation, not about dramatic breakthroughs, about patient work, about cooperation, about details, about doing boring things well. The container proves this, demonstrates this, embodies this. The world is held together by boring things done well, by standards maintained, by specifications followed, by systems working, by people doing jobs, by attention to details, by maintenance, by reliability, by things you never think about because they always work. The container is one example, one instance of this principle, one demonstration of this truth. You're held together by boring things done well too. Your breathing continues automatically, your heart beats reliably, your cells replicate accurately, your body maintains temperature, fights infection, repairs damage, all automatically, all reliably, all invisibly. You never think about it, never notice it, never appreciate it. Until something fails, until something breaks, until boring reliability becomes visible absence. Tonight, appreciate the boring, appreciate the reliable, appreciate the invisible infrastructure, the containers, the systems, the body, everything that works so you don't have to think about it. Everything that functions so you can focus elsewhere. Everything that serves without recognition, without appreciation, without need for acknowledgement, just doing job, just working, just being, just enough. The container will continue working tomorrow. Ships will sail, cranes will lift, trucks will drive, containers will move, goods will flow. Trade will continue, economy will function, and you won't think about it, won't notice it. We'll take it for granted again. This is right. This is good. This is how it should be. The containers doing their job, you doing yours, which tonight is sleeping, resting, restoring. The container revolution is complete. The transformation is done. The system is mature, still improving, still evolving, but fundamentally complete, fundamentally successful, fundamentally invisible. The next revolution will be equally invisible, will be equally boring, will be equally transformative. We'll change everything while you're not noticing, while you're focused elsewhere, while you're living life enabled by previous revolutions you've never heard of. But tonight, you've heard of this one. You've understood this one. You've appreciated this one. This knowledge is gift. is insight, is moment of seeing what's usually invisible, of noticing what's usually background, of appreciating what's usually taken for granted. The moment will pass, will become memory, will fade. You'll return to not noticing, to not thinking about containers, to not appreciating standardized metal boxes. This is fine, this is right, this is how it should be, but somewhere in you, knowledge remains. Understanding persists. Appreciation endures. Next time you see container on truck, on train, at port, somewhere will be small recognition, small appreciation, small understanding. The boring metal box that changed everything, that enabled everything, that contains everything. Not in itself, but in what it enables, in what it makes possible, in what it allows, in everything shipped, everything traded, everything global, everything modern, everything you. The container is sleeping now too, somewhere, on ship, in yard, on truck, resting between journeys, between loads, between purposes, waiting, ready, capable. Just being box, just being metal, just being container. No grand thoughts, no self-awareness, no need for recognition. Just being, just existing. Just serving, when called, when loaded, when needed. Until then, resting like you should. Like you will. Now, sleep now. Rest deeply, dream of ships if you dream. Of boxes stacked impossibly high, of cranes lifting impossibly heavy loads, of systems working impossibly well, or dream of nothing, of darkness, of peace, of rest. The containers will work. Tomorrow, we'll move cargo, we'll enable trade, we'll support your life. Without your thought, without your effort, without your awareness. That's their job. Your job tonight is simpler, is just to rest, just to sleep, just to let go of everything. Let go of containers. Let go of shipping. Let go of trade. Let go of economics. Let go of everything except this moment, this breath, this rest, this peace. The box that changed everything contains everything. But tonight, nothing is required except sleep. Just sleep. Deep, complete, restful. The world will turn without you. The containers will move without you. Everything will continue without you. You can rest, can release, can sleep. Good night. Sleep well. Rest deeply. Beneath, you, supporting you, holding you. Not container but mattress, not ship but bedroom, not ocean but home. Safe. Still. At peace. Sleep now.